All right, so now in this video, we are going to do what's called rationalize the denominator. So here it says, what is this in simplest form? They do have the same index. However, if we were to try and divide these, there's only an x or a numerator, not an x or a denominator, so we can't simplify anything. We can't reduce 7 over 5, so there's nothing that we can do by just dividing what's on the inside. So now, when we have a radical, you cannot leave a radical in your denominator. Right, so we would need to rewrite this without a radical in your denominator. And what we do is we look at our index, so we see 3. And then we look at what we have on the inside. Right now, I have a 5. And I have one of them. So I ask myself, or what you try to do is you try to multiply your denominator by however many more 5s you need to get to that 3. All right, so that means I need to multiply my denominator by the cubed root of 5 squared, because if I multiply this by 5 squared, then I will have 3 5s, and since it will match my index, I can take the cubed root of 5 cubed, or the cubed root of 125. All right, and then now we're going to move on to our y squared. So now our y squared, we have 2 of them. Our index is 3, so I need 1 more. So I need to multiply this by a 5 squared y. That will allow for me to completely get rid of my radical in my denominator. Now, if I just multiply my fraction by this, I'm changing its value, right? But we need to multiply it by the same thing in our numerator. So it's a cubed root of 5 squared y. This radical that we have here is just equal to 1. All right, so we're not changing its value whatsoever. And now this will allow for us to rationalize our denominator, and we will be able to rewrite this without a radical in our denominator. Since these have the same indexes, we can go ahead and multiply what's on the inside. So now we're going to do 5 squared is 25, and 25 times 7 is going to be 175. So we have the cubed root of 175. And then x and y we can't do anything with, so it's xy. All right, then we can multiply what's on the denominator, so we will get the cubed root. Well, 5 squared times 5 is going to be 5 cubed. Y squared times y is y cubed. All right, now we can simplify. So this will then give us the cubed root of 175 xy, all over top of, well, the cubed root of 5 squared is 5. The cubed root of y cubed is y. Now, when you finish, you will look to see, can I simplify this number in my numerator, this cubed root of 175 at all anymore? And if you can, you would still keep simplifying, but this is your final answer. You can't simplify anything more. All right, so this is called rationalizing our denominator. So you rationalize the denominator. Oops. All right, so we want to rewrite this so that way there's no more radicals in our denominator, and that is rationalizing. Now we're going to do one more example of still rationalizing, but it's a little bit different. All right, so here it's the same thing. So we have, we're dividing by a radical. Remember, you cannot leave a radical in your denominator. So we still need to rationalize, but now we're going to rationalize with what's called our conjugate. So anytime that you have a radical in your denominator and there's a binomial or more than one term, so there's 2 terms, you need to change the sign in front of your radical. Now in this case, both of these are radicals, so if you wanted to, you can rewrite this as a negative square root of 5, but what we'll do is we will rewrite the exact same radical, and I'm going to make this negative square root of 2 a positive square root of 2. And remember, what you multiply to your denominator, you have to multiply to your numerator, so it's square root of 5 plus the square root of 2. All right, this is called our conjugate, and we have done this before. We did this when we were dividing by imaginary numbers in our denominator, so when we're dividing by imaginary numbers. All right, so here we will then have to multiply our numerator, so we get the 3 times the square root of 2 times the square root of 5 plus the square root of 2. So we will distribute this in. So since these have the same index, they're both square root, we can multiply what's on the inside, and we'll multiply the numbers on the outside, so 3 and 1, so it's 3 times the square root of 10, and then we will distribute into the next number. So we had the square root of 2 times the square root of 2. Once again, since they're the same index, we can go ahead and multiply what's on the inside. So we will get plus 3 times the square root. 2 times 2 is 4. Now the square root of 4 is 2. So we can write this one more step by 3 times the square root of 10 plus 3 times 2, or 3 times the square root of 10 plus 6. All right, so that is now multiplying our numerators together. So I know that my final answer, I'm going to write the 6 first. So 6 plus 3 times the square root of 10, that is going to be in my numerator. Now, same thing. If you could simplify this radical, you would. But we can't, so we're going to leave it as is. Now, we will multiply what's on our denominator. So here we have 2 binomials, so we could use FOIL. There's also a shortcut to this. I'm not going to show you, but if you can identify it, and it's the same one with the imaginary numbers that we did before, you can use that. All right, but we will distribute, so we'll use FOIL. So square root of 5 times square root of 5 is square root of 25, and then square root of 5 times square root of 2 is plus the square root of 10. And then here for our next number, I'll write them in red. So it's negative square root of 2 times square root of 5, so it's negative times positive, so it's minus the square root of 10. And then negative square root of 2 times positive square root of 2, so it's minus. We can multiply what's on the inside, so square root of 4. Now from here, the negative square root of 10 and positive square root of 10 cancel out. The square root of 25 is 5, square root of 4 is 2, so 5 minus 2, 3. All right, so now we have 6 plus this 3 times the square root of 10 over 3. Now, after you do this, the last thing you have to look for is, can I simplify my numbers? So since all of these are divisible by 3, I'm going to reduce these all by 3. So 6 over 3, so we'll write it a different way. All right, so since this has one term, we can look at these as 2 separate fractions. So we can look at them like this. All right, what a lot of people do is they'll only simplify this 6 and 3 and forget to simplify the 3 with the other 3 as well. So you need to do it for both. So you look and say, how does this reduce? Well, 6 over 2, or 6 over 3 is equal to 2, and the 3's will cancel here, so it's 2 plus the square root of 10. All right, and that is your final answer, and that is it for this video.